All right, so what we're going to do here is we're going to take a look at reviewing our exponential rules, which the true name is exponential laws, the laws of exponential land, or math land in the neighborhood of exponentials. So, what do we know? We know that when we did this the long way, like 3 squared was 3 times 3, and this was 3 times 3 times 3, and we multiplied them all out, we got this. And as we did more and more and more, we found that, oh, wait a minute, we kind of see some rules that like some shortcuts that always work. So that's really what a rule is in math, right? A shortcut that always works. Kind of like multiplication. Who wants to sit and add 2 plus 2 plus 2, 12 times? 12 groups, 2 groups of 12, 12 groups of 2, 24, you're done, right? So these are the rules that we have found that work with exponents. Is this clear to you, or is it fuzzy a bit? It's a bit blurry. Better. Better. Stay. Good boy, stay. Okay. The camera, my dog. All right. So when we do all of this, we know that we can apply these rules, and that's what we're going to be doing. We want to just be practicing these shortcuts. So one of the shortcuts is when you have bases that are the same and you're multiplying, that you just copy down the base if the bases are the same, and you add the exponents. That's the shortcut. And of course, you know that could be that, but it could also be that, and it could even be this. All of these communicate multiplication, right? So that means that if this is a half to the 2 and a half to the 3, that's the same as a half to the 5, right? And no matter what the base is, it could be a decimal, it could be a fraction, it could be an integer. You're just going to find that when the bases are the same and you're multiplying, you're going to add the exponents. And then, of course, we remember that something that doesn't have an exponent really has an exponent of 1, like 2 is 2 to the 1. Then we learned that with dividing, we do the exact same thing. With dividing, when the bases are the same, we subtract the exponents. So if we have 2 to the 8 divided by 2 to the 5, that's the same as 2 to the 8 minus 5, which is the same as 2 to the 3, which of course is 2 times 2 times 2, which is plain old 8. And whether you have integers, whether you have fractions, whether you have decimals, it doesn't matter. If you're dividing, then you have the same base, then you're just going to simply subtract your exponents. Then we went on to the third exponential law, which is when you have a power to a power. So here we have 3 squared all to the power of 3. And of course, this, let me just write it here, is not the same as this, right? So that's a mistake that some people make at the beginning, because whenever you're learning anything new, there's like all this new information coming to you, and you don't really see the little detailed differences sometimes. But now we know that those are not the same, because this is 3 to the 2 plus 3, adding those, which is 3 to the 5, and this is 3 to the 2 times 3, which is 3 to the 6, and of course 3 to the 5 is not the same as 3 to the 6. Any questions? No, this is like cakewalk. Okay, fine. So anyhow, we know here, again, just to accentuate the differences, when the bases are the same and we're multiplying or dividing, we copy down the base and then add or subtract, depending if we're multiplying or dividing. And when we have a power to the exponent of another power, we multiply these two. Okay, Then we moved on to positive and negative exponents. I'm sorry, negative and zero exponents. And we saw that anything to the power of 0 is equal to 1. Each and every time. Then we took a look at what negative exponents mean. And what negative exponents mean, or negative really means change the sign of what you have, because the negative of a negative is a positive, and the negative of a positive is a negative. So I'm going to write that as I say it, because that sounds a little Dr. Seuss-like to me, right? So if you have this, that is flip and do that. And if you have, so back to what I was just saying about, excuse me, a negative. If you have this, and it's negative, and you want to make it multiply it by -1, you end up with a positive. And if you have a positive and you multiply it by -1, you have a negative. So whenever you multiply anything by a negative, or whenever you take the negative of something, really you're changing the sign. It's not like it has to be positive and the answer is negative because you're taking the negative exponent or the negative of anything. Okay? So having said all of that, I think that came out a little bit jumbled, but we're going to just continue on, and I'll, of course, I would never speak to you like that if this was the first time you were learning it. I'm just talking you through a review. So whenever we want to deal with these negative exponents, it just is code for flip the fraction. So if we have 4 to the -7, we flip it and it's 4 to the +7. And of course, if we have fractions, then, and we want to make the exponent a different sign, we simply just flip the fraction, because that's all we did here anyhow, right? When we have this, 6 to the -2, that's really this. We just don't write it like that. So then, to flip it, we have to change the sign of the exponent. And then we, of course, square the top, square the bottom, and end up with whatever we end up with, depending on the numbers we're given. I like it that you guys look kind of bored, because what that means is this is like so easy for you now. Anyone see anything on page 6.3 that they think, oh my gosh, what is she doing? Nope. Excellent. Okay, then we just did more and more and more and more and more and more until we got to here on 6.8. And on 6.8, what we did was we started in question 5. Oh, wait a minute. I forgot about fractional exponents. So we also, I didn't forget about them. This is the first time we're talking about them. Okay, so here, when we have a fraction in our exponent, the denominator, so let's say I just have x to the power of a over b. This tells us what kind of root we have. So what that means is if we have 9 to the power of 3 over 2, that is code for, that means we're going to take the square root of 9 and then cube it. And of course the square root of 9 is 3, and then 3 cubed is 27. Okay? If we have a negative and a fraction in our exponents, so what? You're allowed to have a glass of water and drink a sandwich and eat a sandwich in the same meal. You're allowed to have a negative exponent and a fraction in your exponent all at the same time. So let's say we have this. 16 to the power of -5 over 2. Okay, so let's just decode this. This means take the square root. This means flip the fraction. And this means this is the what you're going to take your answer, the simplified version to the power of, right? So let's take the square root first, or we don't have to, we could flip first, doesn't matter. So let's flip first. So this is really that, so then the flip is 1 over 16 to the power of 5 over 2, and then we're going to take the square root of 1 over 16 and all to the power of 5 when we figure out what this is, and the square root of 1 is 1, and the square root of 16 is 4, and 4 to the power of 5 is whatever 4 times itself 5 times is, right? That's 1, and that's 4 to the 5, which I can't do in my head, and I don't have it memorized for at this moment. Okay, everyone's good? Then we started with these questions where we compared things. So we know that if we have 2 to the power of 2, actually let me make a different number, 2 to the power of 3 equals 2 to the power of something. Well, obviously if the bottoms are the same, the tops have to be the same. There's nothing x can be except 3 if these are going to be equal to each other, right? So with that concept, we started doing things like, let's say we have 6 to the power of x minus 1 equals 36. Oops. Equals 36. That means that we have to make the bases the same so we can compare the exponents. So this is 6 to the power of x minus 1, and this is 6 to the power of 2. And these are going to have to be the same because those are the same, so we write that down, and then we solve for x. X equals 2 plus 1, which is 3. And then, what else did we do? Then we did graphing exponents, and we talked about, okay, so hold on a second.